And the last part is effect of catalyst. So first of all, you have to know what is the function of catalyst. So the function here is to speed up a reaction. How that the catalyst will speed up the reaction? By providing alternative mechanism with lower activation energy. That's referred to EA. Alright, so increasing the forward and also the reverse reaction rates. So to the same extent. So which means that forward and reverse reaction rate will increase at the same rates. Okay. So and then it will shorten the time taken to reach equilibrium. Catalyst not consumed in chemical reaction, just speed up the reaction. So therefore, catalyst has no effect. Remember, no effect on the equilibrium position as well as Kc and Kp. Okay, alright. So we take a look at this graph. Okay, so this is an exothermic reaction. We can see here without catalyst, right? So without catalyst. Alright, so the EA, so the peak here is referred to the EA from here. So this is EA without catalyst. Okay. Alright. So and then with catalyst, the value of EA become lower. Okay, become lower. Alright. Okay. So catalyst lower. Function here lowers EA. Lowers EA for both forward and also reverse direction. So EA is referred to the activation energy. Okay, for example, like this, in the uncatalyzed reaction, uncatalyzed. So meaning that without any catalyst used, okay, the pressure of the gases at equilibrium are also given to you the pressure, partial pressure of reactant and product. What will happen to this pressure if a catalyst is added to the system, to the mixture? Okay, what will happen? So there is no change in pressure. Okay, because catalyst has no effect to the equilibrium position. Okay, alright. So keep in mind. So what should you remember? Right. So these are all the factors that affect that is referring to the Le Chatelier principle or the disturbance. Okay, in Le Chatelier principle. Alright. So if there is changes in concentration, pressure, and volume. So there is a shift in equilibrium direction. However, there has no change to the value of K, no effect, right? So for the temperature, okay, when there is a change in temperature, either temperature increase or lower, okay, so the equilibrium position will shift and it will affect the value of K. Right, and for the catalyst, okay, when we add a catalyst, there is no change in the equilibrium position as well as the value of K remain constant. Okay, just remember, effect on temperature, it will give effect on the shift of the equilibrium and also the value of K. Okay, alright. Okay, we take a look at this exercise. Okay, consider the following equilibrium process between dinitrogen tetrafluoride and nitrogen difluoride. Okay, alright. So given to you here, we highlight delta H is positive value. Alright, predict the changes in equilibrium, which refer to the shift, the direction. Okay, and the value of Kc. Alright, so the first disturbance, okay, the reaction mixture is heated. Okay, so what will happen if the reaction mixture is heated? So meaning that temperature increase. Okay, which mean in the other word, temperature will increase. Right, so for the endothermic reaction here, which mean the forward reaction is endo, the reverse reaction is exothermic. So when temperature increase, system try to reduce the temperature. Okay, reduce temperature. Okay, reduce temperature by absorb heat. absorb heat. So therefore, it will shift to the right side. So it will favor endothermic reaction, shift to the right. So because of that, what will happen to the concentration? We know that Kc is equals to concentration of NF2 over concentration N2F4, right? So we shift to the right, the concentration of reactant product will increase, concentration of reactant will decrease, and therefore the Kc value will increase. Okay, so NF2 gas is removed. Okay, we remove, alright. So meaning that the concentration of NF2 decrease. Okay, right. System try to increase the concentration. That's why it will shift to the right. Okay. So however, because this is effect on the concentration, the value of Kc unchanged. Unchanged. Alright, next, pressure decrease. Pressure decrease, which means the total pressure decrease by increasing the volume. Right, so how that the system try to increase back the temperature. Okay, of course, it try to increase the temperature. So it will shift to the side that is greater number of mole. So when refer to the equation, at the reactant side we have 1 mole. Okay, product side we have 2 mole. Okay, that's why the reaction equilibrium will shift to the right. See, it has greater number of mole. The value of Kc unchanged. Alright, next, inert gas added at constant volume. Partial pressure of the gases does not change since the total pressure increase. Right, so maksudnya P total, we have Pn2F4 plus PnF2. This is after adding, after adding helium. Alright, so meaning that the total pressure will increase. It will increase. Alright, so therefore, each of the partial pressure, okay, for reactant and product, remain constant. Remain constant. That's why the equilibrium does not shift. Okay, meaning that unchanged. No change to the equilibrium position. And because this is referred to the effect of adding inert gas, so the Kc value does not change. Okay, alright. So this is example application for the Le Chatelier principle in Haber process. Right, so Haber process is industrial preparation of ammonia. Okay, so and then this is the equation. The value of delta H is negative 91.8 kilojoule, which means that, okay, the forward reaction is exothermic, the reverse reaction is endothermic. Okay, so how that the Le Chatelier is applied in Haber process? Okay, so we actually we want to maximize the amount of ammonia formed. Okay, in order to increase the amount of ammonia here, so the direction of the equilibrium should always shift to the right. So meaning that how that it can reduce, it can proceed to the right in terms of concentration. So first we can reduce the concentration of ammonia or by remove the ammonia. Alright, so the system will shift to the right. Okay, in order to form more ammonia. Okay, next, in terms of volume, so can reduce the volume. Okay, because of that, the pressure will increase. Okay. Okay, so when reduce the volume, so pressure will increase. So system try to reduce the pressure, total pressure. Okay, reduce the total pressure. It will move to the side that has less number of mole. Okay, since when refer to this equation, At the reactant side, we have 4 moles. And at the product side, we have 2 moles. So that's why it can shift to the right side. Okay, by reducing the volume. Okay, so it will shift to the side that is less number of mole. So this is how that we can increase the how to maximize the formation of ammonia. Okay, in terms of temperature, right, reduce the temperature. Okay, why reduce the temperature? Okay, system try to increase the temperature. Increase the temperature. So, it will release heat. Release heat. So, it will favor exothermic. So, I refer back to this equation, exothermic. Okay, so negative value, which mean forward reaction is exo. Reverse is endo. So, that's why it shift to the right, favor exothermic. Okay, alright. So, exothermic reaction favor cooling. Okay, alright. So, the yield is favored by lower temperature, but the rate formation is not. So only lower the temperature. The rate formation is not affected. Okay, in fact, NH3 form is so slowly at low temperature. Okay, because of that, the process become uneconomical. So maksudnya because of in order for this factor, okay, reduce the temperature. It will form more NH3. However, the formation becomes low. Alright, so industrial condition. So at high pressure, okay, and continuous removal of NH3, so are used to increase yield, which means the formation of ammonia. But the temperature is raised to moderate level, and catalyst is used to increase the rate. Okay, rate. Achieve the same rate without a catalyst required much higher temperature. Okay, as a result, in much lower yield. Okay, so this is a line, okay, CaO, used primarily in the manufacturing of steel, glass, and high quality paper. It is produced in an endothermic reaction. Okay, kata endothermic. By thermal decomposition of limestone. Okay, how would control reaction condition to produce maximum amount of lime? So meaning that is mentioned here endothermic, which means the forward reaction is endo, reverse reaction is exo. So now we want to produce the amount of lime which refer to CaO. CaO to increase this amount. Okay, how that we can increase? So first, this is the how that we can choose. Right, so the reaction here is endothermic for the forward, endo. This is exo. Alright, so the ideal condition to maximize the production is the system always shift to the right. How to shift to the right? First, we can increase the temperature. Okay, increase the temperature, which means system try to reduce the temperature but absorb heat. So that's why it favor endothermic and it will shift to the right. Okay, and then low pressure to the side with more moles of gas. Okay, in terms of pressure, right? So when refer here, it's not considered zero, and we have 1 mole. Alright, so meaning that pressure should be low so that it will shift to the side that has more number of mole that is referred to the right side. Okay, and lastly, remove continually CO2 as it form, which refer to the side product, CO2 gas, the side product. So as it form, we remove the CO2. So the reaction will always proceed to the right side in order to form more CO2 gas. Okay, alright. So that's all. Thank you.